Hi there, this is Coach Suiso, and welcome to this video of a demonstration of a titration. Today we are going to be titrating to equivalence point. I've got my safety goggles on, I've got my lab coat on, and my hair's tied back, so we're all good to go there. Let's talk about the setup just a little bit, and then we will proceed with our titration. So I've got a burette here, and it measures by milliliter, as you can see. And the burette is attached to a ring stand. I've got a funnel at the top for ease of adding my titrant. It's got a stopcock at the bottom, which is keeping my titrant in the burette. And below it, I've got my Erlenmeyer flask, and I have a stir kind of machine. You can use hot plates, sometimes have stirring. And this would be a magnetic stir rod. We're not gonna use this today because we don't have a lot of these. So if we were doing this in person, we wouldn't necessarily use it, but I wanted to show it to you because on our online lab, this is present. And so we want you to be familiar with this concept. So I'm gonna go ahead and move this because we're not gonna use it. And I'm also going to lower this so it's a little bit lower so everything's a little bit more accurate. So let's talk about what we've got going on here. In my burette, I have my titrant. In this case, it is 0.1 molar of sodium hydroxide. So I know the concentration of my titrant, and I'm also going to know how much of it, my volume, that I'm gonna end up putting into my Erlenmeyer flask. But down here at the bottom, in my Erlenmeyer flask, I've got my analyte, which in this case is an unknown concentration of hydrochloric acid. I do know that I have 10 milliliters of hydrochloric acid in there, so I do know my volume, but I don't know my concentration. What are we saying? Oh, is it 20 milliliters?
Yeah, it's 20.
Oh, that's okay.
Okay.
Well, I'll just edit that out. Or I'll just put at the bottom like it's 20 milliliters of it. It's fine. Okay. All right. I'm going to start exactly where I'll edit it out. I also have phenolphthalein, which is my indicator for today. So phenolphthalein, I'm going to add it to my analyte in just a minute. In the presence of acid, phenolphthalein is clear, so you're not going to see it. However, in the presence of a base, phenolphthalein is a very dark kind of magenta pink. And at the end point, or the equivalence point of our titration, it's going to turn this very light baby kind of color pink that's extremely difficult to get, but that tells you that you have reached the equivalence point of your titration. Remember, here we are trying to interact and react the moles of my titrant with the moles of my analyte. So if I needed to add water to my reaction at any point during the time, that's okay. It might change the concentration, the molarity, but it's not gonna change the moles of my hydrochloric acid that are in there, and that is what we're actually doing the reaction with. So I'm gonna go ahead and start by adding my phenolphthalein. A few drops here. And you'll notice it's clear. I don't remember how many drops we added in the past. Miss Werner, how many did we add?
That's enough.
That's enough, okay.
And
All
then
right.
when you start a titration, you always want to record the initial volume.
Yep. All right, so I'm gonna just make sure my phenolphthalein is kind of mixed in. And again, I'm manually gonna be agitating this and stirring it because we're not using a magnetic stir rod. So what I'm gonna do, I'm going to open my stopcock and I'm going to let my titrant go into my analyte here. I'm gonna do it very carefully. At the beginning, it's not as big of a deal because you've got a ways to go, but I'm gonna be really, really careful as I get later on into the titration. So we open it slowly. I'm gonna let some in. Move my hand so y'all can see. And there we go. So you notice it turned pink at the bottom, but when I stir it, the pink goes away.
Where it turns pink, because phenolphthalein is that magenta color in the presence of a base. Where you add that pink, that was the base. And then the acid comes in and neutralizes it, so you still have an acidic solution setting here.
Exactly. It's important to stir it after every single, especially when you're beginning and you're learning, because you just don't know how much you're gonna need to add to completely neutralize this acid. We're getting there, and this is a process. So you gotta be really patient.
And one thing you might want to think about since we've done these titrations, you look at that, oh look, there's the base. Nope, the acid just neutralizes, so it's still acidic. Oh, there's the base. So as long as it's clear, it's still an acidic solution.
sure, give it a good stir here. Getting closer.
The key with the titration is tedious, and you got to be patient.
Patience. That is not my strong suit, Miss Warnell. We're getting there, we're getting there. So I'm gonna start going a little bit slower here. See, I'm just adding kind of drop by drop here.
When you do a titration, hopefully many of you will do these in college. How good of a titration you get is also...
Okay, so what happened here? I put, when I kind of was doing it drop by drop, I ended up putting more of my base into it than I needed. I crossed that equivalence point. And so now you'll notice the color is this kind of bright magenta because in the presence of a basic solution, phenolphthalein is bright magenta. All right, so we have gone over here. So we've got a basic solution. So in order to bring it back to an acidic solution, I'm gonna add more of my analyte, okay? So I'm gonna use a pipette here and I'm going to measure out the amount that I'm gonna add. I'm gonna add 1 milliliter because now I started with 20 milliliters of my analyte in here. If I add 1 milliliter of my acid, now I have 21 milliliters in my analyte, and that's going to adjust my calculations when I later go back and try and figure out the molarity of this unknown analyte. So let me measure out my 1 milliliter. Perfect. Got 1 milliliter, and I'm going to pour this in. Again, the first thing I should do is write down that I have added 1 more milliliter in here because that's going to be important for my calculations. So you look, it's gone back to that clear solution because now it's an acidic solution. I've gone back to the other side more or less of the equivalence point. So we have more of the acid in here than we do of the base. So now we know we're super close to that equivalence point. So I'm going to be even more careful and go really drop by drop to see if we can get that light pink. So here we go. We basically backtracked. Drop. See again, the base, drop. We're very, 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 very close. And the beauty of doing the titration is that you can backtrack. Oh. So it should stay when you shake it.
And some common errors with this is you might have a drop on the side of your flask that takes a little bit to get down.
Yeah, like this.
Oh my goodness. And
it's
then
so stressful.
You've added more drops because you didn't realize it was stuck on the side.
So you just want to be really careful, especially even these drops kind of at the end of your burette. If you don't mean for it to fall in. Yeah, I'll tap it.
Yeah, tap, tap, hurry. That's that surface tension.
Connections, all the units. Bonding. Look at that. Hydrogen bonding. I'm going to let it go. And there it goes. Let's see. We're close. We're close. Ooh, that was 2 drops. Oh. You notice how it's lasting longer every time I stir it. We want to get to the point where it'll last about 30 seconds when I stir it. Oh. Okay, like 1 drop maybe.
Right, you still have it. Yeah, okay, good. 1 drop.
You don't want to have to go backwards again. All right, here we go. Let's try this 1 drop here.
And then move it. In case another drop falls. Move it from under. Yeah. I think that's
about as close as we're gonna get. That's within 1 drop.
And that's not as light as you would want it, but we are at the whim of these burettes. And at the bottom, this drop size is pretty big.
Yeah, it's big. Those are big. So normally it would be a hair lighter than this. Imagine like kind of like a light pink, kind of like a baby pink. But that was 1 drop difference. So that's about as close as we're gonna get. We did a pretty good job. So our last step would then be to come up here, because we need to know, remember, we know the concentration of our titrant, but we did not know the volume. So now we would measure, we started at 19.1, now we're at 28.6. So we can determine exactly how much of our titrant that we added. So now we can carry on with our calculations to determine the molarity of our analyte. And that's all we got. Thank you so much for watching. Go ahead and answer the questions that are below, and we'll see you later.